Hi, I'm Jack Buffington for robotbrigade.com. This is another video in my series of videos about a open source mapping robot that I'm working on. And in this video, I'm going to talk about a RPlidar node that I have made for ROS2 and am using in my mapping robot. Hi, I'm Jack Buffington for robotbrigade.com. This is another video in my series of videos about a open source mapping robot that I've been working on. And in this video, I'm going to talk about a RPlidar node that I made for ROS2, and I'm using it in the mapping robot. Originally, I wasn't planning on using ROS2. I was planning on just writing everything from bare bones, but then I changed my mind. But before I changed my mind, I wrote a class that allowed me to read the RPlidar. And when I switched over to ROS2, I thought, okay, I'm just going to find, surely Slamtec has a ROS2 driver for their RPlidar, and that was incorrect, at least for ROS2 Foxy. And so I adapted the class that I made to work as a node for ROS2. And there's some slight issues with that, but I will go over that in a moment. The first thing I'm going to do is I'm going to look at my code here. So let's look at the class that I wrote. And the first thing that you do when the class is constructed is I need to find any RPlidar that's connected to the system. And at this time, I'm assuming that there is only one. So the way I'm searching for it, because I'm not just going to assume that it's on a particular port. That tends to lead to problems. So I am searching the first 10 possible TTY/USB-X ports, even if they aren't necessarily there on the system. And when I manage to open one up, then I am sending a get health, as shown right here, a get health message. And I'm not quite sure what this is telling me from the RPlidar. I forget. I wrote this a decent amount of time ago. But I'm checking right here to see that I got a valid response. If I did, then hey, I found an RPlidar, and I call it good. And then when I need to destruct this object, the first thing I do is I stop the LiDAR. And by stopping it, I mean stopping it from spinning. By default, when you power up this LiDAR, it is not spinning, and you have to send it a command to tell it to start spinning. Then I go ahead and close the serial port. That makes sure that it's not just spinning away forever doing nothing, just sucking down current. So start the LiDAR. This makes it so that it starts sending you the scans. The way that this class is working is I have a thread that I'm spinning off that actually does the reads, and it reads until it sees that it finished up a scan. And then it, using a mutex, it pushes that buffer over into what's accessible to the main program. And so there's never a conflict between the main program reading a partial scan of one and a partial scan of the new one. That's not a problem. So read range data right here. This is the function that does the actual reading. I'm going to say that I'll leave the specific details of this for you to read through on your own, but this is using the express scan mode of using the RPlidar. And there are two modes. The first one is what I've seen for the other ROS nodes and basically all the code out there, which this RPlidar is capable of 8,000 data points per second. And what I wrote is able to read in that mode. The mode that I've seen everybody else using does about 4,000, and that is a I don't know what they call that mode, but the express scan that I've implemented is sort of a compressed format, and the other format sends the angle and the reading directly, and so it's more straightforward for sure, but I wanted as much data as I possibly could get. So yeah, I'm not going to go over what it's doing. I will say that the way that I implemented this is sort of a combination of reading the data sheet and sniffing the data that their demo program is generating, because the data sheet was not sufficient to actually implement this mode, but their tester program does use the express scan mode, and so I just hooked up my logic analyzer to the serial port here, and I sniffed the data. And so you'll see in various places in this code, I've left some commented stuff in there that was the data that I read, but then I determined that I didn't actually need to do that to get the thing to work. Stopping the LiDAR. This is, publicly accessible function of the class, method of the class. So setting the PWM, here are some experimental values that I found. I suspect that this sort of varies by temperature and how cranky the RPlidar is that day, maybe by age, I don't know. These are approximate values, so if I set a PWM of 100, then I'm going to get approximately 3,600 readings per revolution. Has good health, so I'm calling this basically in the beginning. So let's see. Read response. This is reading if I send a command such as get health. This is reading it. And here's send get health. So now I have implemented the low level stuff of what it actually sends out the serial port. Here's send a PWM value. And then here's some other stuff that I read with my logic analyzer that I ended up not needing. I commented it out, but I left it in there just in case I need to reference it. But realistically, I haven't needed to, so I could probably get rid of it. Send stop, obviously that's pretty clear cut. Send express scan, so that gets it going with the scan mode that I'm using. Calculating checksum. So pretty simple. I've got stop, start, and send PWM, and then read the scan. For my node, like I said, I'm adapting it into the ROS2 format, and so I'm taking what the RPlidar sends to me and I'm converting that into a ROS2 laser scan message. And initially when I started doing that, I had trouble because think of making a big jello or very soft rubber piece and printing your map on that, and then you just slap it, right, and then the map's kind of wiggling around like that. Initially I was saying, okay, well, I got 306 data points back from the RPlidar, so let's just split up the full circle by 306 and just assign each one to that. But as it turns out, the RPlidar doesn't send out its data with regular angular intervals. And so this is making all the map kind of wobbly. And so what I ended up doing after scratching my head for quite a while of trying to figure out why my map was so terrible, but when I plotted it before, it looked good, I realized that the angles weren't regular. And so now I am quantizing the angle. So I'm approximating. So let's say I want 300 data points. Then what I do is I tell the RPlidar a pulse width modulation value that gives me maybe 330 data points. Okay, and then for each data point that I get, I check that angle and I figure out which bin it should go into. So if I said 300, then I've got 300 bins, and so I find the closest bin to the angle of the return data point and stick it in there. And I'm asking for extra because it is wobbly. I'm probably still missing some of the bins, but doesn't really matter. So that's basically what I'm doing here. So for this node, I have a few things. I've got RPlidar. I subscribe to the RPlidar on topic, and if I send it a 1 or a true, it starts the thing spinning. If I send it a 0, it stops spinning. I can tell it points per scan, and so then if I say 200, then it gives me exactly 200 points in the return. And then the scan divider, right now, I don't know how useful this will be. I suppose it all depends on how you implement your software and what you want to do with bag files, which I'll explain in a later video. But initially, when this starts up, it's taking every 10th scan and publishing it as a laser scan message. By setting the scan divider to 1, I can send out every message, or I could change the interval to 20 or whatever I want. Let's see. So this is checking. I have in the class, I also have a free running counter that increments every time there's a new scan. And so the method that I'm using is I'm checking to see if there is a new scan by checking that variable. And once I have that, then I go ahead and I'm quantizing it into the bins, and then I'm publishing it right here. And this is the callback that gets called when it receives a message on the RPlidar on topic. Same for points per scan, and same for scan divider callback. And this is just sort of a little bit of boilerplate to get it so it actually runs. So let's see how this actually works. I'm going to switch over to a terminal now, and I've got the robot running. These two, the top left and bottom left, are of the robot. And this right here is my laptop over on the right. So the cool thing about ROS 2, at least, I'm not sure about ROS 1, is that it's publishing everything using UDP cast? I forget. Basically, I can receive UDP messages over the whole network. And so my robot's over here on my right, and you know, my laptop is on the network, but it's not connected in any manner to the robot. But I'm running ROS 2 on both of them. And so the first thing that I need to do in each of these terminals is I need to source the setup.sh. Where did it go? There it is. Oops. Well, I've actually technically already sourced it. I'm just trying to show you the proper way of doing it. But I'm not in the right directory to source that. And then here I have made a, where the heck did I have it here? Okay. I have made a Python program. I wanted to use RViz, but something is misconfigured about RViz on this laptop. And in the sake of speed, I just chose to use Python with matplotlib to show me what's going on. So when I initially run this, nothing shows up. Over here, I'm going to run the RPlidar node. You can see that it found it. And nothing's happening yet because by default, when it starts up, it is not spinning the motor. So down here, I'm going to send it some commands to turn it on. So once I turn it on, you're going to start to see packets coming over here, and my map will show up. So here we go. I'll make this a little bit bigger. And I'll try to make it square. I didn't write my program so that the axes were equal. Right here at 0, 0 is where the RPlidar is located. And right here is me. And you can probably see as I wave my hand around, I'm moving. I have it sitting in a corner. But this is kind of slow because, like I said, I have a scan divider. So I'm going to take and change that to show me every scan. There we go. And so now my updates are happening at a much higher rate, and you can see as I'm moving around with my arm here that it's getting faster updates. I'm going to show something else. What was it? Oh, just the scan rate. There are points per scan. So let's say I do 1,000. Now watch how like an area like this starts to really fill out and it gets more data points. Oh, I wanted to tell you something else actually. The RPlidar is catching stuff over here. It's just falling off of the map. I am getting complete data for the full sweep, but I just decided to draw it so that 0, 0 is right at the center. And I think this will be more useful in the future when I'm driving the robot around. So that's it for the RPlidar. I hope you enjoyed this video. I will be publishing all of the information about this on my website at robotbrigade.com in the tutorials section under the open source mapping robot. I'll also be putting other videos in a series on YouTube, so take a look for that. So for robotbrigade.com, I'm Jack Buffington.